Now comes the most critical component, or rather, the critical surfaces, the bearing surfaces, which are going to interact with the bolsters. For those of you with the book and a keen eye, you'll notice that I deviated a little bit from Kozo Hirooka's book. I have good reason to do so, and I'll get to that here in a moment. But first, come on over here and join me at the bench, and let's make some chips. Oversized stock material is never a lot of fun. It takes a lot more passes to get into dimension. Sometimes you have to make the most of an opportunity. And I found, especially with this setup, that machine-like particular cuts. And removing this extra material gave me an opportunity to practice my finishing cuts and really dial in my speeds and feeds and get the perfect finish. So that when I came to my final dimensions, I was really able to give it the best possible finish on that bearing surface. Even when taking a climbing cut on a finish cut, this setup just did not react well and did not leave a good finish. A little tip here, one of the things that I had learned by the time I was finished cutting out all these columns was it was better to reduce the width of the columns to that 311 or 312 and then cut the top face or the bearing surface of these columns. And by doing so at 311 using a 3/8 or a 0.375 cutter, I was able to finish the cut in just a single pass. I began with material approximately 3 inches in length. The finished length of the columns is 1.25 inches. So that means I'm going to have approximately half an inch, or if evenly distributed, a 1/4 inch of material to remove. Now, if I was taking 20,000 passes, we're looking at something like, what is it, about 12 passes and a set of finishing cuts. Unfortunately, the bandsaw I'm using, the vise is positioned a bit far away from the blade. In terms of work holding, these small 1.25 inch parts are not going to be held very well, and it's a little wobbly and insecure. I've got to go at it the old-fashioned way and use some elbow grease. And believe me, by the time the 6th one was done, I was exhausted and my arms looked like Popeyes. I should have ate my spinach this morning. I think in a future build, I'm going to have to figure out a way to make an extension for my vise. With this scale of a train and all these little fiddly parts, an extension would be fantastic. If you got any ideas, please post them in the comments below. I could use a little bit of help and inspiration to figure this one out. bump off of my newly machined bearing surfaces. Because those interact with the bolsters, I'm going to treat those as my most critical dimensions and base the placement of my internal threads off of those surfaces. Except for the fact I'm not using a small iron drill and tap, I'm pretty much sticking to the book by using a number 47 drill bit. I have found the 47 provided enough hold clearance I was able to successfully tap with 3 48 TPIs, and only when I had converted over and only used good quality sourced American tap. Now, if you have to use low quality taps or you're having difficulties, one of the things you can do is switch over to a slightly bigger drill bit, in particular a number 46. So basically the next size up. Still keeps you within a class 2A and 3A of the max internal thread diameters, according to Machinery's handbook. And that is your journeyman trick of the day. So that's something you may want to consider. Since it's going to get all soldered together and locked up anyways and has to be drilled out, it is not actually a critical feature of this part that requires high tolerance or will really affect its performance. Essentially, it is a work holding feature that is temporary because it will be removed with the final machining operations. Since I have chosen to use 60 thou sheet metal for my build of the columns, I'm going to have to deviate a little bit from the book. I know from experience this metal is going to warp and twist, especially from my experience of welding a lot of it for completed projects, failed projects, and just to practice on. Soldering is going to bring the material temperature up to 1200 to approximately 1400 degree Fahrenheit range. Even with brass sheet metal, it's going to go out of gauge and twist a little bit. One of the things that the writers and I believe it was either Martin Evans or LBSC wrote in their books. I can't remember exactly which because I read both their books back to back and a lot of their words are unfortunately blurring for me. But the person had said that it seemed like steam locomotive trains were just about perfect and broken imperfect right before they were worn out. And some of this can be contributed to the fact that things twist and go out of shape due to the high temperature inputs from soldering. Let me kind of show you what I mean. With the input of that 1200 to 1400 degrees, that metal can bend out. Or worse yet, it might twist funny. As you've seen, I've chosen to drill and tap both ends. While Kozo Hiraoka uses a 1/64 tap and thread, a smaller one, and then drills it out to the 3/48 thread, that is kind of a difficult no start for me since I'm using steel. That tiny thread and tap is just a hassle and breaks quite often. And you really need to use a high quality American made tap, as well as not necessarily drill a hole that is on the tighter end of things, but is on the larger end. By drilling and tapping a through hole on the sides of the columns, it's going to allow me to essentially turn the columns, as well as the screw that I use to bind them to the soldering jig, as sort of a cinch nut, and really hold them in place so that they don't move around with that input of heat. Additionally, since I'm using a big square cube that has a high interior volume, it's going to essentially act as a bit of a heat sink. So heat traveling up the columns away from the joint is going to be sucked away and pulled into the cube and not affect the rest of the part. You see, I didn't bother cutting this because this is going to be machined off. So I'm going to mount it in like this in the vise. I'm going to machine this surface, bring down my cutter, machine this surface. So these two will be nice and perpendicular. And then turn it like that. Do the same, machine this surface. For overall length, this was cut at about 80 thou. So I'm only going to machine this just to get this all removed and cleaned up, and this all removed and cleaned up and parallel to one another. And then I'll machine this, so that'll be 4 of the surfaces. And then I'll turn it, and then this surface will be brought all the way down to 0.626, and this surface will be brought all the way down to 0.625. So that on one side, it's going to be a gauge for 626, and one side a gauge for 625. So that I can, after soldering things and everything goes haywire, bent, and screwy, I'll be able to use this as a gauge to bend everything back into shape. So let's do the old tap, tap, tap. Yeah, that thing's like moving the entire bench now. Ooh. The way I like to be consistent with my twists is that tightening, so I don't, one, over tighten, but two, to get a more consistent vise setting, is that When this plastic handle just begins to turn and twist like that, that's where I stop my tightening. So I use this plastic handle as kind of a built-in torque wrench. There is not a gap of light at all. That is nice and square. I am stoked about that. Since I'm going to be drilling a through hole, I don't feel too worried about using that 46. Here, I'm going to go ahead and use a 47. The Z-axis, or the feed on the shear line, is a very different experience and feeling than you would get on, say, a drill press, because it is designed differently and uses hand wheel. I would say that the hand feel that you, or feedback you get while drilling, not very responsive to what the drill is doing. So I'm not able to rely very much on what's going on at the hand wheel side of things. So I've got to pay more attention to how my chips are getting evacuated, as well as what the drill bit is doing, particularly on these really fine and tiny ones. I can actually see it flex a little bit if I got too much feed, and as soon as that happens, I really quickly need to back off or I risk snapping the drill bit. Now I'm going to go ahead and use a taper tap since it's a through hole, and it allows easing and starting it in to be a little bit easier. You'll notice that I went ahead and got it as up high into the chuck as I possibly could, so there's less opportunity for flex and breakage. Throughout this process, I'm going to be using copious amounts of cutting fluid. Cutting fluid is luckily readily available and fairly inexpensive compared to broken tabs and scrap parts. I'll be using a little bit of welding rod and kind of treating it as sort of a plunger to flush out this through hole. With a drop of cutting fluid and forcing it through, it'll clear out some of the chips and make tapping a lot more smoother and easier. Since this tap is a bit short and it's tapered, I'm going to go ahead and send it in all the way and then go in from the other side. Now I want to be careful here. I don't want to end up having threads cross one another when tapping the other side. Otherwise, I may snap my tap. And if that happens, well, luckily I've machined the other two sides as well. One is not going to be large enough because it's a bit smaller to gauge in a tight area on the columns. And the other is just a bit oversized so that I can take down with either some emery cloth or remachine it and take off just like half a thou, maybe a thou, to bring it into that 0.6255. This tap isn't quite long enough to go all the way through. So I'm going to want to go about halfway and then flip it over and come the other way. Now that our machining's done, I can start to focus on assembly, or rather joining the parts together through soldering. The only little part left to make is this going to be the top bar that connects the two columns. I, of course, am going to be using a little bit of recycled material. So, I don't know if you could see that horrible, nasty welding. An old practice piece of material from back in the day when I was practicing TIG welding. I really appreciate that you've chosen to spend your time with me and watch one of my videos. If you enjoyed that, be sure to hit the like button. And until next time, have fun out there, stay safe, and keep making chips.